everyone, and glad to be here at the Open Source Observability Day. And today I'd like to talk to you about OpenTelemetry, the vision, the reality, and how to get started. My name is Dotan Horovits. I'm a DevOps specialist and a developer advocate. I've been working in the DevOps and observability space for many years with vendors, with the open source projects, with the community. I'm also a CNCF ambassador. CNCF is in the Cloud Native Computing Foundation with a special focus on cloud native observability. And I also run the Openobservabilitytalks podcast, which talks about DevOps, open source, and of course, observability. Check it out on YouTube or your favorite podcast platform where you get your podcasts. You can find me everywhere at Horovits, on Twitter, Medium, Mastodon, LinkedIn, YouTube, whatnot. So feel free to reach out after the talk if you have any questions and comments. So let's start with observability and the vision. The observability, as we all know, is the ability to understand the state of our system based on the telemetry data that it emits. And the vision talks about unified observability across different signals, primarily logs, metrics, and traces, although we'll see that these are not the only ones, and also, very importantly, across different sources. So think about your front-end code, your back-end code, open source tools, cloud services, everything you have in your ecosystem and your stack, essentially fuse all of these together to gain unified observability. That's the vision. The reality, however, is much more fragmented, as you can see here. And that's because we use many tools for our observability. And each tool and each vendor has its proprietary APIs and SDKs for instrumenting. Think about your Datadog agent, Splunk, New Relic, whatnot, and client libraries. And then they also have proprietary agents and daemons and collectors to collect and run aggregation, sampling, and other processing. And then its own protocol and data model to transmit the telemetry to the analytics backend. And all of that is not only an operational headache and a vendor lock-in issue, of course, but it also creates tight coupling between the telemetry collection and the telemetry storage and analysis backend, which makes it very, very difficult to correlate data between and gain unified observability across these essentially data silos. And that's what OpenTelemetry comes to solve. So OpenTelemetry, or OTEL, as we call it on the CNCF in the project, is as you can see here, the definition, an observability framework for generating and collecting telemetry data from cloud-native systems. So it's one system across all the observability pillars: traces, metrics, logs, and others. It's an incubating project under the CNCF, the Cloud Native Computing Foundation. It started as a merge of Open Tracing and Open Sensors, for those who know these projects, and has been accepted to the CNCF sandbox back in 2019. So it's been around for quite some time and in incubation since 2021. And now let's start with what's new with the project's adoption and activity. And the most exciting thing for me as an ambassador for the project is that it is today the second most active CNCF project, second to only Kubernetes itself, which is, of course, very impressive. This is taken from the CNCF dev stats. It's taken for the last 30 days, but it's been consistently so for a long time. And it's really very active. You can see some numbers. It's probably already outdated, but just you get a sense, like 50-something thousand code commits, 70,000 pull requests, hundreds of thousands of contributions, and very importantly, over 10,000, I think by now, individuals contributing code, and over 1,000 or 1,100 companies contributing code. And the big news, because of these health signs and the activity of the project, it is OpenTelemetry is applied for CNCF graduation, meaning that it's going to go to the highest level maturity, open source maturity level, which looks at all these vital signs of an open source project, like the project governance, the number of active maintainers, diversity of the contributing organizations, and so that, as you saw, is very, very healthy in this case. So really exciting, and looking forward to seeing this coming to fruition soon. And now that I hope that I convinced you that OpenTelemetry is indeed a major thing and a major trend in our industry, let's go over the main components of the project so you can understand what it's comprised of, and then we can go over the different details. So as you can see, OpenTelemetry offers a unified set of vendor-agnostic APIs, SDKs, and tools for generating and collecting telemetry data. This is the sort of the bluish part on the left-hand side, and then a unified way of capturing and exporting that data. This is the green part, and then sending it to whichever backend tool you choose. OpenTelemetry as a project does not provide a backend, so you can choose to send your telemetry to Prometheus, to Jaeger, to Zipkin, to so proprietary vendors or whatnot. It's up to you, and it's really open. So that's the project in a nutshell, but don't worry, I'm going to dive deeper into each and every one of those one by one. But first, I would like to start, before going into the components, into something that is not a component, but rather governs all of these components. And this is the OpenTelemetry specification. The specification describes the cross-language requirements and expectations for all of OpenTelemetry's implementations. So as you can see, it has the API spec, the SDK spec, and the data spec with semantic conventions and so on. And this comes to solve the pain of fragmentation, that each vendor and each programming language and each signal has its own convention. And another important point is that a unified data specification and semantic conventions will also enable correlation across the signals and across the sources to get that unified observability we talked about before. So that's the OTel specification. And now the first component that you're likely to meet is the client libraries. OpenTelemetry provides one API and one SDK per programming language based on the unified specification for instrumenting your application. So you have a Java one, a .NET one, Python, Ruby, and so on. You see the logos here. It also has language-specific integrations for popular web frameworks, storage clients, RPC libraries. And for many languages, it also offers an automatic instrumentation agents that can collect telemetry from some applications without requiring code changes. So, and this could be very easy ramp up on your application. And also in some cases, it's mandatory if you have like third-party frameworks or other limitations that you cannot change the source code. So you have to use auto instrumentation. So as you can see, OpenTelemetry aims to provide the full range from fully manual to fully automated instrumentation and anything in between. The next component I'd like to talk about is OpenTelemetry Collector. The collector can collect data from the OpenTelemetry SDKs as we talked about before, but also from other sources. Think about Kafka, MySQL, Redis, cloud services, whatnot, and then export this telemetry to any supported backend. And as you can see in the diagram, it's built like a typical data processing pipeline. So we have receivers in multiple protocols, then processing and aggregation, and then exporters in multiple protocols. So you can collect telemetry from our application, back and front end, or from other infrastructure components. You have a Kubernetes receiver, Docker receiver, Kafka, MySQL, HTTPD, AWS X-Ray, GCP PubSub, CollectD, whatnot. And then you have different processes to do things such as filter, modify, batch, sample, and so on, which is very useful to do all sorts of edge processing like redact PII, drop unnecessary data to reduce cost, enrich with geolocation, everything else. And then you can also chain different processes to get more elaborate processing logic. And then you have exporters for many backend tools depending on your choice. So you can export to AWS X-Ray, Azure Monitor, Google, Datadog, Dynatrace, Splunk, Sumo Logic, all the major vendors, of course, open source like Prometheus, Jaeger, Zipkin. You can downstream to Kafka to do more batching. So this is the collector in a nutshell. And the last component I'd like to talk about is OTLP, which is the OpenTelemetry telemetry protocol, which is essentially a general purpose telemetry data delivery protocol. You can use it, as you can see in the diagram, between the telemetry, the SDK and the collector. It could be used between the collector and the backend or any other intermediary node. It's really a general purpose protocol and request response style, client server communications. As you can see here, it's implemented over gRPC and HTTP 1.1 transport. So you can use OTLP over HTTP and OTLP over gRPC. gRPC, of course, is the most efficient, but you can also use HTTP where gRPC is unavailable or not well supported. In terms of the encoding, as you can see, it supports binary protobuf encoding and also the newer JSON protobuf encoding for the payload. So you can have OTLP over JSON that is already stable. And it's obviously based on the data model that we have from the specification. So this is the internal representation over the OTLP protocol. So these are the main components I'd like to cover. And now let's talk about the status of the project, okay? And this is the status not as the open source maturity that I talked about before, but rather the software maturity component, whether it's GA or beta or whatnot. So let's start with the state of the different signals, the primary signals, the traces, logs, and metrics that some people call the 3 pillars of observability. So I'm glad to say the first one to have graduated was traces. It's been around for a good few years already. Everything is stable, and you can see a rich suite of client libraries for many, many languages: Java, Go, .NET, C++, JavaScript, Python, really a rich ecosystem. Second one to have graduated was metrics, and where there you can see we have client libraries for also a good few, maybe not as many as traces, but still Java, Go, .NET, C++, Python, PHP, and many more. And you have, of course, the collector supporting metrics pipelines, and Prometheus support is also important because, again, in the cloud native ecosystem, Prometheus is very much a de facto standard for metrics. So you have, in collaboration with the Prometheus community, the cross correlation, the OTel SDK support Prometheus exporters. In the collector, you can receive, you have Prometheus receivers, Prometheus exporters, Prometheus remote write exporters, of course. You have Prometheus to OTLP data model specification alignment. So this is on the metric side. And the last to have graduated actually this year was the logging piece, where you have everything already set. You have both logging integration with existing logging systems. So in essence, fetching logs and transmitting over OTLP. And you also have a newer, essentially, alongside the legacy unstructured logs, there's work on a new strongly typed machine readable logging format that has been generated under OpenTelemetry. And in that respect, I'm glad to share a very exciting update that the Elastic Common Schema was merged into OpenTelemetry. So you probably know Elasticsearch, very popular. Well, it used to be an open source and a very active community. So that community and all the knowledge that has been accumulated within this community about logging and structured logs and schema is now being part of the OpenTelemetry semantic conventions for logs. Now let's talk about more updates beyond the basic signals and components. I'd like to go quickly over several items here. And first of all, looking beyond the 3 pillars of observability, I'm glad to say that finally we're going into newer signals. And the first one that we've identified as a community is continuous profiling. So we've established a special interest group specifically for profiles in order to define and actually earlier this year, the data model for continuous profiling has been merged, as you can see here on the screen, into OpenTelemetry. So now it's a formal part of the OpenTelemetry specification, a remarkable journey led by the SIG, the Special Interest Group for Profiles. And actually, I hosted members of the SIG on my podcast, Openobservabilitytalks, for a special panel discussion on this very, very important milestone that happened around the KubeCon. a great discussion. So check out the QR code, and they give a lot of insights about why it's done, how it's done, what's supported, and what's the roadmap for this integration going forward. Another very important step in OpenTelemetry is moving into real user monitoring support. So the first focus was around server-side type of flows, but now needing to monitor client-side interactions from a web app, from native mobile apps to the backend. And that can be done now using the real user monitoring, being able to ask. And of course, you could also do that before with JavaScript SDK, but we didn't have within the standard a way to express things that are end user on the client side, being able to ask questions like counting the number of new users versus returning users, visualizing how users navigate through the application UI, identifying pages that generate high number of errors, all these sorts of typical flows for real user monitoring. We didn't really have the entities like session ID and other things that represent client-side interaction. So now this is another very important focus. You can find it in the CNCF Slack under OTel client-side telemetry, or you can already see PRs and issues in the GitHub repo for that. Another topic is the ease of operation. So beyond expanding to more types of observability is also being production ready and easy to operate that in production. And a lot of that things have been done. There's a Kubernetes operator that has been released already over a year, and advances there like support for feature gates and so on. But also, as you can see here, there's work on what is known as the OpAmp or Open Agent Management Protocol that supports different functionalities like remote configuration of the agent, status reporting, and the agent's own telemetry reporting over OTLP and so on. So this is a lot of activity that's been done around the operability of OpenTelemetry. You can see here the implementation. Another very important thing with OpenTelemetry is eBPF auto instrumentation. So eBPF, for those who don't know, it's like a kernel level implementation code that can run in kernel level, so it can run underneath the individual programming languages, which enables you to do auto instrumentation in a much less language dependent manner. And there's already effort around doing that in Golang. There's a Golang auto instrumentation agent impact, and you can see already additional languages adopting this and exploring this usage of eBPF for auto instrumentation for different scenarios. So very, very interesting advancement. Now, another very important thing with the project is the ability to ramp up new users and start very easily. And for that, the OpenTelemetry project launched a community demo that has reached general availability in the past year. So with this demo, you'll be able to quickly run a complete end-to-end distributed system, instrumented 100% with OpenTelemetry traces and metrics and so on. So very easy. A mock-up called Astronomy Shop, essentially like an e-commerce shop, as you can see here on the screen, and very diverse mock architecture that can really give you a way to easily explore OpenTelemetry. Another important point I mentioned before, if you remember, that OpenTelemetry started as a merge of Open Tracing and Open Census. So it's important to know that Open Census is no longer, it's essentially officially sunset, officially archived, also Open Tracing. So if you are still using it, now is the time to move to OpenTelemetry. But the nice thing is that if you did use Open Census, know that you have full feature parity with Open Census in C++, .NET, Go, Java, JavaScript, PHP. So, and of course, better yet, OpenTelemetry offers a richer ecosystem of instrumentation libraries and exporters and all the things that we talked about before. So again, I hope that I convinced you. Now is the time to move to OpenTelemetry. So that was very briefly about the updates in the project. And now I'd like to say a word about how to get started with the project. So people might get confused, and this is why I would like to provide it's a massive, massive project, of course. If you look at the GitHub repo, you'll see how massive it is. So here's my bit of advice on how to get started. So when coming to evaluate OpenTelemetry for your project, you should map the status of the relevant components for your system. And as you can see here on the screen, know your stack. And these are the main questions that you want to ask yourself. First, which language? Okay, you need to understand which programming languages you use in your application. It could be different languages for front end and back end. Many organizations has polyglot or architectures. So, and this will help you map the client libraries that match the programming languages that you use. Potentially also agents for instrumenting programming frameworks you use in your code. So if you use Node.js with Happy or Express, or if you use Java with Spring, try to map these frameworks, programming frameworks that you use, which also will help you then go and see, hey, I have auto integration with Spring Boot out of the box. So that's one thing. Secondly, ask yourself which signal types are interesting for you. As you saw, OpenTelemetry supports many signals, but you need to understand you want tracing, metrics, logs, profiles, and then also from which sources. Okay, is it infrastructure components like Kubernetes, Docker, HTTPD, AWS X-Ray, GCP PubSub? You need to really understand from which sources, and also which protocols, especially if it's brownfield and you have existing, I don't know, component that sends out tracing data in a Zipkin format, and you can't change it. You need to adhere to that. So this will help you understand and determine the receivers that you need to use in your OpenTelemetry collector. And then lastly, you need to define which analytics tools you use for your backend observability analytics. And that will help you determine the exporters that you need to use from OpenTelemetry collector to send out this telemetry to your tool of choice. So these are the main questions that you need to ask to know your stack. And once you have that, then go and check out the relevant components for your stack and for your needs. You have here the link, the status page for OpenTelemetry, opentelemetry.io/status, and lots more relevant URLs and links like the docs, of course, the registry that helps you navigate through the massive GitHub repo, and of course the GitHub repo itself for OpenTelemetry. I can also suggest checking out the guide to OpenTelemetry that I wrote, which gives a good beginner's entry point for OpenTelemetry. It offers an in-depth coverage of all the components we talked about today, like the SDKs, the APIs, the collector, and so on. It also has sub-guides for individual programming languages like a Java subguide, .NET, Node.js, Python, Ruby, and so on. So you'll definitely find it easy to set up a hello world to get your feet wet with the project. So this is OpenTelemetry in a nutshell, and you have the QR code here for the guide to OpenTelemetry to check it out. As I mentioned before, you can find me everywhere at Horovits. So feel free to reach out to me if you have any feedback on the guide, on the talk, or any questions. And of course, go ahead and try out OpenTelemetry and get involved in the open source project. I'm Dotan Horovits, and thank you very much for listening.